Welcome, everyone. My name is Iñaqui Delgado. I'm the Android tech lead for the video product here at Twilio. We just wanted to mention that we're actually going to have a number of WebRTC talks at the Twilio conference that's happening in SF next week on Tuesday and Wednesday. So if you are interested, just talk to someone from Twilio and they can hook you up. So prior to joining Twilio, I spent a good portion of my time working on a WebRTC app at a startup called Tristan. And I built the app for both Google Glass and a number of other Android devices. This experience allowed me to understand a lot of the pain points related to WebRTC. And this past year, I've had the opportunity to take and build on that experience to try and provide an Android SDK for WebRTC. So there's quite a bit of work that you have to do to adopt WebRTC on mobile today. Part of it is learning the build process, learning the APIs related to peer connection, media, session management, and in addition, you also have to bring your own signaling. So it requires you to set up some server infrastructure, implement a signaling implementation for your end clients, and also take into consideration the need for some kind of network traversal service. So one of our goals at Twilio has been to simplify that barrier to entry to use WebRTC. And so we've built a cross-platform C++ API for the mobile SDKs that we provide on both iOS and Android today. This cross-platform C++ library encapsulates both the WebRTC portion as well as the signaling infrastructure that we built. Obviously, one of the big benefits is that we get to share this implementation across both iOS and Android. But in addition, we've actually built this platform on several desktops like Darwin and Linux to perform testing. And we've also engaged with 2 customers that are interested in using the same platform on embedded devices. And lastly, there's a benefit to you as the developer. The benefit being that when we make changes to the signaling component, or when WebRTC makes changes to their library, we still provide you with a consistent API so that you don't have to make those changes yourself. So what does this API look like? So we wanted to provide a simple and easy to understand model that represented a real-life entity. So in this case, we picked a conversation. So in order to create a conversation, you either have to invite someone using an outgoing invite or receive an incoming invite. Once you either send an outgoing invite and the remote participant accepts, you are then placed into a conversation. And at this point, the local media that you've set up is now shared with those remote participants. And in addition, those remote participants that are joining the conversation are able to share their remote media with you. This model really maps all the way down to many of the components that we're all familiar with in WebRTC. One of the benefits that I think you gain from using our API is that there's really no signaling specific interfaces that you have to deal with. So today I want to talk about some of the challenges that we've had on the Android team building an SDK for WebRTC. So I'll talk about some environment challenges that we had with the Android platform itself, some issues with fragmentation, and I'll provide some concrete examples. And lastly, I'll talk about some platform threading and media-specific issues that we've had, and describe what we're working towards. So one of the first challenges we had was dealing with a pretty fractured development environment. So out of curiosity, how many of you guys do like NDK development on Android? All right. So I think all of you probably know that the development experience, at least up until early this year, was actually pretty rough. In fact, up until just a few months ago, our SDK still lived in Eclipse. We had a lot of challenges just doing basic things like native debugging. We found that that environment was unreliable, and in fact, that environment has been deprecated for some time now. Actually, I think sometime in 2015. So one of the reasons why we hadn't made the switch from Eclipse to Android Studio is that the Android Gradle plugin did not fully support using external static libraries. So our project depends on a number of static libraries, like our core library, but also we actually package boring SSL separately, and we have a couple other helper libraries that we pull in. So early, I think last year, the experimental Gradle plugin actually added support for bringing in these static libraries through the Android Gradle plugin. So since then, we've migrated our SDK to Android Studio, and we've been able to reap all the benefits of the platform. So we can now easily manage both Android and static dependencies. We have a fairly fast and stable native debugging environment. And we get to build our SDK alongside our test app. So we're no longer building our SDK through Eclipse or through the command line, and then having some janky script that copies things over into our Android Studio environment. So that's been a huge win for us on Android. And if anyone is considering doing anything native with WebRTC or just native development in general, I highly encourage you to take that investment. And there's a link here where we actually wrote a blog on this. So if you're interested, feel free to check it out. So people talk about fragmentation a lot on Android, and these are kind of some numbers to sort of highlight. So there's I guess over 24,000 devices on the Android platform today. There are 4 architectures that people commonly use. So ARM AVI v7a, ARM64, x86, and x86-64. And today, technically speaking, WebRTC actually supports 96% of the devices that are registered with Google Play. So there's a massive number of devices that technically support WebRTC. So today, our SDKs run and we build against all 4 of these architectures. And we perform testing on approximately 30 devices across a number of different, pretty popular manufacturers. But it turns out, just testing within these devices, we've actually encountered a number of device-specific issues during our QA process. So some of these are actually like specific to certain OS levels, and others are defects in the devices themselves. So an example of this is prior to API 21, in some cases, if you try to load a native library, you would get an unsatisfied link error, which there's actually a very popular open source library called Relinker, which solves this problem for you. But this was actually something that a customer reported to us in a previous SDK that we worked on. And so we've taken that and integrated it into our SDK. And so that's kind of like a platform-specific example. But in addition to that, you also get a lot of errors related to like opening the camera. There are errors related to rendering when certain devices actually don't claim to support OpenGL, but in fact don't seem to support it. And then we've also had cases where we'll get like one-way audio in some cases. And so what's interesting about these issues is that, you know, as an SDK developer, you always have to kind of decide how much time you want to invest in each of these individual bugs that you encounter on very specific devices. So another challenge that we had initially was actually settling on a threading model. So in our initial implementation, we actually had multiple handlers responsible for propagating events to the developer. And we actually found that having multiple handlers was actually not a very good idea at all. We realized that many of the events that were coming back up from our C++ core library were dependent on each other. So if you had separate handlers dealing with each separate event, one event may have needed to be a precursor to another event. And so we've simplified our threading model, and now we call back on a single handler that gets created when the SDK is initialized. And so this is a pattern that I think Google has adopted across a lot of different media libraries. And the nice thing is, like, this isn't really visible to the developer per se. So 99% of the time, the developer is going to initialize the SDK on the UI thread. And as they would expect, they're going to get notified on the UI thread by all the listeners. So lastly, I wanted to talk about one of the requirements that we had, which was to allow developers to preview the camera before starting a conversation. So initially, our core library was not implemented to allow local media to be retrieved prior to initiating or joining a conversation. So people that are familiar with the browser, you know, this is something that you kind of get for free. And we sort of made this mistake early on, and so we thought, well, we'll work around it. We'll use the camera preview pipeline that's already ships with Android. But in fact, that actually led to a number of like inconsistencies between our preview and the rendered local video once the conversation was started. So I tried to show an example of that. You can kind of see on the left and the right, the aspect ratios are a little different. The resolution might actually be different. So let's see. So right now we're actually in the process of refactoring our implementation to allow us to use local media for both the preview and the live conversation. So this refactor is actually part of a much greater effort to improve our media capabilities. And media is more than just about the camera. In fact, we're working to generalize our capture APIs to allow other forms of media into a conversation. So we've found that developers are interested in implementing their own captures or their own renders for their particular use cases. So as an example, we've actually started working on a screen capture for Android, and I'd like to demonstrate that today. So this is our JavaScript internal test app. So I'm just gonna log in, and I'm going to listen, and then using my Android phone here, I'm gonna go ahead and start a conversation. Okay, so I'm gonna mute, and so as you can see, you can see my. I should probably disable all of the audio. There we go. So you can see my screen right now, and in fact, I'll pull up Angry Birds, and oops, here we go. And we'll just, play for a little bit. So you can see the frame rate is actually pretty snappy. So along with screen capture, which we hope to ship in the near future, we'll also be adding a more generic capture API, as well as exposing the data channel. So that's it. Does anyone have any questions? What is the frame rate? All right, let's see. It's a good question. Let's see. So we're getting looks like it was at 45 when I turned it on. Hold on. Let me. That way, I'm not. So the local media here, you see the 1280 by 720. So it seems to be. It looked like it was between 30 and 45 frames per second. Looks like it's staying pretty steady at 30 right now. So, I've seen it as high as 57, I think. So it's works pretty well. I guess one thing to note is this only, or it doesn't only work in Lollipop, but the API that we're using, which is the media projection API, was introduced in Lollipop. Any other questions? All right. Oh,
yeah, sorry. It's interesting that you guys are going to do data channels. Are there any driving use cases for data channels?
So data channel has actually been something that we've talked about a lot, and we have some other products within Twilio that can solve there are products that we're working on that can solve many of the same use cases that people want on data channel. But I think ultimately we should just give the developers both options and have them decide, what option is the best for them. So
do you collect any of the performance metrics for the frame rate?
Yeah, so
Can you compare with any other product in the market?
Sure. So as a developer, we give you access. So what you just saw here was just like a developer API. So you can get stats related to tracks, and this is what WebRTC provides you out of the box. We just propagate that information up. In addition to that, we have webhooks, which allow you to know when certain conversation events occur. So when you start a conversation or a participant joins or leaves, or if a conversation fails, you can be notified of that immediately. And then internally today, we have, we're collecting sort of metrics on certain calls, and our goal is to provide a product called Insights, which will allow you to gain insight into what's going on. Go ahead.
Did it support the VoIP user?
Yeah, so I guess I should have mentioned that. You can actually call, you can start a conversation with multiple participants. Right now, this is peer-to-peer, so we've capped it at 4. In the future, we do plan on supporting a multi-party service that can scale at more than just 4 participants. But I think you might be able to see it here. If you look at the bottom there, it says like there's an invite. So you can either invite multiple people when you start a conversation, or you can kind of ad hoc add people as you're already in the conversation. So, go ahead. Sorry. Is it what? Right. Yeah. So as I was saying, as a developer, you get access to to the statistics that are related to each track, each audio and video track. And then we also provide these webhooks that give you insight to like what participants are joining, which conversation. Each conversation has a uniquifier called a SID. So if someone reports a problem, you can actually go and look up which conversation it was and map back to potentially even see like why it failed, like why the conversation may have failed. All right. Thank you very much.
Thanks, guys. We're going to jump right into Tristan's talk. Joining us from Textme. He's the architect there, and he's going to walk through really quickly deploying WebRTC app and how quickly that can be done today. So with that, I'll give him the floor.
Hi guys, so let me just plug first. And today we're going to show you how quick and easy it is to set up a proof of concept WebRTC platform with a video conference enabled server. We're going to use only open source software to do that, and it's going to be less than 10 minutes, so bear with me. Yeah, just switching the screen on. So first of all, to speed up a bit the presentation, I took some shortcuts. Already provisioned an AWS server, already did some Let's Encrypt certificates. Okay, got it. Yeah. It's quite jumbled. Nice. And little bit better. Huh? No. Okay. So let's see if nice. And with the console, is it okay? Is it better? No? No. It doesn't like the console either. Okay. Well, it's going to be quite difficult to show you something there. But we will quickly go through it anyway. And at the end of the run, anyway, I prepared a small bash script to show you that. Yeah, well, okay. I'm going to have to read the bash script.
Resolution. What if you change the resolution?
Well, let's try that. Good idea.
Okay.
Nope.
It's fine.
Yes, it's okay. Okay, this one is
Funky. All right.
yeah. So let's get started. Let's get started and. And just a few steps that we're going to run on this server already provisioned, which basically we will set up a repository. I'm going to use FreeSwitch server. I don't know if anyone, if someone is familiar with that open source SoftSwitch SBC back-to-back user agent. Seems like yes, good. So I'm going to install a FreeSwitch server with their demo configuration. Just going to run that there. Run that script. It's going to take a while, actually. Time to download maybe 300 megabytes. Doing nothing, yeah. That's how easy it is. We're installing FreeSwitch. We're going to just quickly configure it with a few regex per replace in the configuration files. The idea is, of course, to stay with their demo, and we're going to install also an Nginx server, set it up with the Let's Encrypt created certificates, so we can have, at the end of this run, a working lab to have a video conference system. Yeah, there's a lot of package and dependencies installed because FreeSwitch, starting with the version 1.6, do some video transcoding. It's a lot of dependencies that we're going to install. The point of that is to show you that building a proof of concept platform is very easy. It takes less than 20 minutes. Actually, the script when it runs takes something like 6 minutes. Quite easy. You don't want to do that in production. You want to use real tools to deploy the configuration like Chef or Ansible or not a bash script like that, but for the demo, it's okay.
It needs Erlang.
Yes. Yeah, I'm pulling all the FreeSwitch packages right now. There is a lot that are not needed for this demo. Erlang mode is not needed, of course. I'm just pulling the meta package and did not trim it down. So that it's allowing the demo to have all the features available in case you want to test it. In a few minutes, I will require your assistance, by the way, to go on the URL that I will give you, already configured previously, but it takes something like 1 minute to configure. So that's not a problem. Okay, we're at the end of the FreeSwitch installation. All right, so now what we're doing, we are installing, FreeSwitch is already installed. We're installing Verto Communicator. Verto Communicator is a soft phone in the browser created by the FreeSwitch team. That works quite well too. It's using a protocol called Verto that the FreeSwitch guys created. It's not SIP. You can use SIP also if you want, it's not a problem. This configuration allows you also to use SIP if you want, but for the purpose of the demo, I choose to go with the Verto protocol, which is basically a JSON-RPC protocol. There is still SDP for the WebRTC fan here, but it's lighter than SIP, and for the purpose of the demo, it worked quite well. As a return, it works quite well also when you start scaling. That's interesting to know. We don't use that at Textme, we use SIP because we needed to have some retrocompatibility with our apps that use SIP, of course. And so we built the web app that we have using SIP.js as the stack. Just a few modifications we made because we made a few modifications of the SIP standard internally for our needs. We don't need any interoperability, so we took a few liberties with the protocol just to get some lighter packets, let's say that. Yeah, it's doing all kind of stuff that I don't know because I'm not a UI guy, I'm not a front-end guy, I'm a platform guy. And this is compiling the JavaScript for the Verto demo. All right. They used Angular indeed and Node.js to build their Verto Communicator soft phone, which, as you can see, takes as long to compile as to install the whole platform. Interesting to know. And it's over. So now we are able to go to that website. It was set up right in front of you. WebRTC.remote-shell.net, which is my domain, whatever, a test domain I have. And we have a working platform to do some video conference. If you join me, Ari, for example, and call extension 3500, we are doing video conference, mixed on the server.
What's the domain?
remote-shell.net. WebRTC.remote-shell.net. And it should work also on the mobiles.
What's the path?
There is no password. It's already set up inside the
On the path.
on the path /VC.
support WebRTC.
Oh. And we have Ari join us. Good.
You have to say yes, by the way.
Oh, HTTPS.
Yeah, HTTPS, yeah. It's a demo. I didn't set up the redirection of the HTTP to HTTPS using Nginx, but
You said the URL again? Is it webrtc.remote.shell.net?
.remote-shell.net/bc. And we're adding some participants. All right. And I'm on my phone right now. We have the same UI on the phone. All right. So that was it, guys. Set up a conference server in less than 15 minutes. It's done. Less than 10 steps in the shell script. I can show you it back if you want. Yeah, it's a small instance on Amazon, so video transcoding is taking quite a lot of resources, especially as we're doing the mux. It's not SFU. So of course, it's just a lab, it's a small demo. I encourage you to check out what the Free Switch guys did because it's pretty awesome. Very, very good work done there. And it's a first step to build a platform that can go to production. There's a lot of different elements when you want to go production. You don't do a single server, you do the balancing. Well, you all know that anyway, I think. I hope. And that's it. Easy. I encourage you to try our web app at textmeup.com if you want to try it. It's feature powered with the mobile app to see what we can do with Free Switch actually in production. And do you have any questions?
So what browser? What browsers? What mobile browsers? Either of the ones on my phones.
Chrome or Firefox. Safari won't work at all because
iOS kicks out the
Firefox works on Chrome.
So what's the scalability of Free Switch?
What's the
Scalability.
The scalability? Quite good actually. If you do video transcoding like that and video mixing in real time, it's a lot of resources.
So how many parties can
On
support one server?
M4X large instance in Amazon, for example, you can go up to 30 participants. But you're going to see some very high loads on the server. After that, it starts to get very scrambled, and you don't want to use that. If you want to scale correctly these kind of conferences, you have to provide a way to auto-scale your instance and provision them in real time when the users want them. Maybe keep a small instance in batch separate, but that's it. You can't rely on having thousands of video calls at the same time. If you're doing only audio mixing, though, that can scale to a lot of users on the same server. I was speaking about 30 participants for video. On the same server, you can go to 1,000 participants in audio, and it will go fine. Provided that you're using a codec that is not too heavy also. Audio codec is not too heavy. But it works fine with Opus. I did some tests and some benchmarking with Opus, and that was fine, so should be good. Yeah.
Thank you. Yeah. So just to confirm, so you had a like more or less a blank Linux server, and then you ran that shell script that installed a whole bunch of stuff.
Yes.
That's open switch, so that does the signaling and also the video transcoding.
Yes.
So Free Switch. I'm sorry, Free Switch. And so then if you have those 4 people who are all connected, so they're not doing WebRTC directly to each other, but to the server, and then the server is sending video back.
Yes, we're doing all the maxing of the video feeds on the server, the audio feeds too, of course. Audio is cut there, but yeah.
Okay, that makes sense.
Yeah, the connection is with WebSocket to FreeSwitch and the the virtual communicator with with Nginx. That's it.
So, one last question. Why do you need to do transporting and pre-switching if it's just packet forwarding?
Because you don't want to have SFU if you do mobile video conference. You don't want to send your mobile thousands of megabytes of data to do the mixing on the mobile. You have to do the MCU, you have to do the mixing on the server.
So it's a mixing.
Yeah, mixing all the streams together on the server. That is what is using a lot of CPU actually.
Thanks for the question, guys. If there's more questions, we'll leave some time at the end for anyone to talk with any of the speakers. I think Tristan will be here, and if there's any more questions. Other than that, join me, give me a round. Keep going quickly. Next, we've got Caesar joining us from Chalkbox, and he's going to walk through some of the challenges again on kind of implementing WebRTC on mobile.
Go, Cesar. We got more beer here, so we know it's a little warm, so grab some drinks. Don't hesitate. I know it's they're working in the AC. Everywhere I go, they're working on the AC. Sam knows that. Everywhere I'm at, it's always the venue AC. All right, Cesar. You're not going to glitch. Don't glitch on us. Yay! That's 80% just getting the first chart up here. Let you watch that.
Hello, my name is Tristan. I work at Dutton. Today I'm going to present this using WebRTC to create a mobile cross-platform SDK.
Can't hear. Cesar, get the mic on. You're a live speaker.
Thank you.
This is how they turn my mic off.
So today I'm going to cover 3 points: SDK versus application, and challenges that we have found around WebRTC mobile, and quality and interoperability testing. This is the first point. And when you are building an application, you always know the use case, but building an SDK based on WebRTC is not the same. So we don't know what the developer is going to make, right, with our SDK. So we have to be prepared to be used on a lot of different use cases. Some of them, even maybe the video communication is not the most important part. Maybe you can have video communication integrated inside a game. It's something that we don't know in the past. And WebRTC is always evolving and improving, but that means also that it's changing, and sometimes the API changes and all these things. So at the end, providing an SDK, we try to solve this and to make a stable API. That way you can implement your use case, you can implement your use case without caring about the modifications or the improvements. You have to focus on your use case for your application. Right? And our customers expect that we hide all these changes under our API. And also, we have to provide extensibility. As we don't know the use case, we have to provide this kind of extensibility to allow to implement everything, right? And for example, here we have an implementation of a canvas-generated feed on Android, video feed, sorry, on Android. And this can be used, for example, on our customers is using this, that is the capture API to create mobile screen sharing, for example. That is a use case that is not very common in mobile, but you can do this. As Iñaqui was commenting, our approach to create that was the same that Iñaqui was commenting, to create a cross-platform SDK. At the end, we support 2 mobile platforms, Android and iOS, with all the architectures. And we support as well desktop platforms, like Windows, OS X, Linux, and also we support tvOS, for example. And yeah, the benefits of this is that we can share all the code base across all the platforms. So there is a big gain doing that. Our core library is written in C and C++, as well as WebRTC. And we try to do our code platform, code library, as platform independent as possible. And we try to make all the bindings with the native platform as small as possible to improve the maintainability. And we use CMake to compile everything, and NPM as dependency manager. That is mainly we use that for WebRTC. It's a very big dependency, and we use NPM internally to get the dependencies. And what we do that is very platform dependent, that is the capturing and rendering pipeline. It's something that is very platform dependent. And here what we provide to our customers is an open source implementation, so they can make the modifications specific for their use cases. So this is something. Next point is the challenges that we have found around WebRTC for mobile. And one of the big issues or challenges that you have on mobile devices is the CPU. It's not the same as a desktop computer. So there is a trade-off here because you need more CPU to have more better video quality at the end or better resolution. But there is always a trade-off. You need more CPU, you have less battery life. And you can use PP9, for example, then you have to use more CPU to get less bit rate. At the end, all things depends on the use case. And we don't know the final use case. We have to try to provide options to the developer to do that. And yeah, the use case is very different if you are going to implement one-to-one or multi-party. We have to provide alternative in this case. For example, like in the example of the game, maybe you don't need HD video for this application or use case. Maybe you are going to render a very small video. So even there are some use cases that even with a video frame every 5 seconds is okay. It depends on the use case. What we try to do to improve these issues that we have, for example, hardware encoding and decoding of H.264 on iOS, for example, and this improves a lot the battery life and the CPU consumption, right? But in some cases, here we have some graphics that PPA software encoding and decoding versus CPU versus H.264 hardware encoding and decoding. But even if you need more CPU, you can go to audio only. This is something that we have to provide all these options. Right? Another big challenge in mobile is the connectivity. In connectivity, it's very easy to change from network to network. It's something that is the mobility that you have on the mobile. And usually, when we design things for the video communications, we don't think on all these things that happen on mobile. And for example, if you have to connect to Wi-Fi and the 3G
他不是到那个秋季才发吗？
Who is the guest?
那个这个摄像头怪怪的。
发吧。
还有那个巴拉克的，
这个手机问题啊。
Thank you. The thing is, sometimes we only think in the video communication. Sometimes we think if the 3G network is better than the Wi-Fi that I have right now, I'm going to use the 3G network. But this is something that we, as an SDK, we have to be careful. And we allow the developer to choose because, for example, on some countries you pay for the data, right? And it's something that you cannot do automatically. Also, as an SDK, we have to manage all these connectivity issues and provide a simple API for the developer to allow to modify the UI these are the Android devices that are connecting to our platform in the past 5 days. There are a lot, and we cannot test all of them. We try to do our best, but it's something that is very difficult, right? And sometimes you cannot do a specific optimization for a device. It's very difficult to cover a high percentage. The thing is, another issue with mobile is that the update cycles are longer than the web. Usually, us as an SDK, we have 2 update cycles at the end. We have the developer that can decide to use our latest SDK or not, and also the final user that is using the application of our developer, and he or she can decide to use the latest application or not. So we have to deal with that because we cannot force people to update or to upgrade. And we have, for example, these are in the past 5 days, people using our SDKs. We have even people using an SDK that is 1 year old. So we have to deal with that, right? And the only way to deal with that is testing. We have interoperability testing between our versions, SDK versions, and also depending on the use case, because sometimes depending on the use case you need a web browser also, because you can call a web browser. We have to do interoperability testing also with Firefox and Chrome. We use Chrome and Firefox beta, and we have our custom tool to do the interoperability testing between all the versions. That is a very big matrix. And the good thing is we can detect issues even before they are reported. It's a good thing for a testing tool, right? And also the thing is every version that we have of an SDK, inside we are using WebRTC, and we are using a WebRTC version, right? So if people are using all the SDKs, that means that people is using all WebRTC versions. So we have to compile and to backport a lot of fixes from WebRTC, because we try to use always the latest, but if people is using an old SDK, we have to keep to maintain the security and the improvements on all these SDKs. So we have to backport these fixes to all WebRTC versions that are not supported right now. So, and we do this using Jenkins. We automate all the builds. WebRTC is a very huge repository. It's like 10 gigabytes. So it's something that is very difficult to maintain if you are not automating. So yeah, that's summary. Building an SDK is not the same as building an application. We have to think more use cases. We have a lot of connectivity challenges and performance challenges in mobile. And we have to provide quality on our SDK. Even that the WebRTC has a lot of testing, we have to do also because we have other challenges here. So, that's all. Questions?
So you mentioned you use APM for dependency management for C and C++?
Yeah, correct.
That's surprising. Can you speak more to that?
Yeah, at the end, you can use NPM for everything. You can package whatever you want. So what we have is an internal server, Sinopia, I think, yeah, internal registry of NPM. And we use it to manage all the WebRTC dependencies and also the internal dependencies of the SDK. So it's working very well. At the end, yeah, we don't have to carry in. All the compilation that we do is doing CMake, so we have created some steps on CMake to use NPM install, and you can use it. Cool. Yeah, we are very happy with using NPM.
Yeah. Not so much a question, more like an ask, like, please do test for Firefox Dev Edition, not like beta. Because if you guys like run any servers, like I work for Mozilla, so if you run into any issues with beta, we're only going to fix security issues. If you report like any problems in beta, tough luck. If you report something in Dev Edition, you get a chance that we still fix it before it gets released.
Okay. Thank you. Any other questions?
You know, in that big eye chart you showed with all the different Android devices,
Yeah.
So that's kind of scary looking from a testing point of view. Would you say that it's, from your experience, is it better to focus on versions of Android as opposed to independent devices? Which metric do you find more defects in your own testing? Is it in the Android? Is it in the Android release, or is it on the individual device, or is it a combination of the two?
Yeah, in the combination, the thing is that on Android, you cannot rely on the newest APIs. Usually the older APIs work better. That is impressive, but and sometimes you can find bugs on a specific device. This is something that's very difficult to manage. So if you keep your code as platform independent as possible, is the best option. And yeah, at the end you have to capture video and to render video. So you have to do. You have to pray sometimes. It's very difficult.
You have any automated audio or video quality tests?
Yeah, the thing is we have some automation for that. It's very difficult at the end to automate, and we rely more on manual testing for these kind of things. But also we try to automate everything that we can. At the end, we can inject video from one side, and the rendering, we can save the video to a file. So with only visual inspection, you can see the video quality. So it's not a hard thing to do it manually or something like that.
Great questions, guys. We got to move on to the next one. We just got 2 more talks for it. Tom. And we've just got 2 talks left. We've got Tom, and then we've got Sam and Justin going to give the presentation from Google. And then we'll wrap up and give time for everyone to ask their questions to the speakers. Continue to talk. We've got some more wine out and some more beer in the back. If you want to grab something, feel free to take a second to grab a drink. The bathrooms are on the 2nd floor.
Good evening. My name is Tom Hughes, and I'm an engineer at Airtime. And tonight I'm going to be talking about mobile group video with WebRTC. So first, I just want to play this video really quickly to give you an idea. So first starting off, so WebRTC it's got a peer connection, so it's peer-to-peer, right? Well, what happens if we set up a peer-to-peer fully connected mesh topology with 6 devices, for example, the number of devices that we currently support in a video chat? Well, then you have a connection like this, where everyone is sending their video to everyone else and receiving all the streams from all the other people. This is bad for a couple reasons. One, you have network constraints. You're on a mobile network, either Wi-Fi or cell, and you have the other thing is
wait for the speaker.
The other thing is the way that WebRTC is set up with a peer connection. Each peer connection, as it's sending, is going to be actually encoding for each peer connection. So in this case, one person is going to be encoding that stream 5 times. And the reason for that is WebRTC's CPU adaptation dynamically changes the bit rate on each one of those. So even though ideally you'd only be sending one, and encoding once, you're encoding multiple times, and that's really expensive. So let's look at another potential topology. So we can do central topology with star topology. We have a media center in the middle, or media server in the middle. And so in this case, now we only have each device sending one stream up and receiving multiple streams. The nice thing about this is that only a single stream is being encoded. But we have a couple things that we need to add and deal with in order to make this work well. So one, we need end-to-end network adaptation, because you're having a single stream that's sent up to the server, and the peer connection is terminated on the media server, but you have multiple subscribers, each under different network conditions, different latency, bandwidth, packet loss, and so that server is going to need to adapt for that. The other thing you need to handle is the end-to-end CPU or performance. So you have this single stream being sent up, but it's being received by a heterogeneous group of subscribers. So you may have an iPhone 6s sending up a stream and it being received on a low-end Galaxy S3 or even a desktop device, and so you need to deal with those situations. So first I'm going to talk about the network adaptation part. So as I mentioned before, the network conditions are different for each subscriber, so we need to adapt each one of those independently. So some of the strategies we can do to reduce the bandwidth on the receive or subscribe side are, one, reducing the frame rate by dropping frames. Now, you can either do that on the server with temporal layers, or you can actually do it all the way back at the publisher at capture time, depending on the exact set of participants you have in the video chat. The other thing you can do is reduce the resolution. So that you can do transcoding on the server, or again, you can push that all the way back to the publisher to avoid doing work on the server. So obviously, if you do the transcoding, that's going to require more server resources, versus frame dropping is much less process intensive for the server. So if you do the frame dropping first, you can be able to support more streams on a single server. Worst case, we always want to preserve audio. So worst case, we can just drop video completely and preserve audio to preserve the continuity of the conversation. So another thing you may ask is, what about simulcast? It's available in WebRTC, so can use that. But that tends to use both too much of our precious resources, such as bandwidth and processing, again, in that case, encoding multiple times. So that's not really a great thing to do on mobile. So let's just see an example here. In this case, we have the publisher on the far left there, and it's on a good network connection, and that's represented by the green as well as the thick lines. And each of the frames that are being sent are labeled A through F. But we have three different subscribers, one with a good network situation, one with a middling network situation, and one with a poor network connection. So the one on the good connection is receiving all the frames at the full frame rate and the full resolution. The one in the middle is only receiving half the frame rate, and that is the server dropping half of the frames. And then the one with the poor network condition is receiving both half the frame rate and a transcoded lower resolution. And then obviously you can imagine as the bandwidth changes, that will vary over time. So now let's talk about performance. We're not on the desktop where we have lots of extra processing power and battery life. As this graph kind of demonstrates, we have an exponential increase in processing power even over the last few generations of devices, and so we need to handle that. So the biggest thing you can do to help with the performance is adjust the amount of video data processed. So we can use the same strategies that we use for network, including limiting the frame rate and limiting the resolution. And then we can also limit the amount of data processed by the capabilities of the device. And so this can be either a hard-coded lookup table. For example, iOS devices are pretty easy to do with that. Or what we do on Android is basically check the CPU and we have a benchmark and basically a rough graph that we match to estimate the performance. In addition, if you let WebRTC run on its own, it's going to take up all the resources on the device happily. So what you can do is, and what we do, is create a processing budget to split the resources between the app and our audio-video WebRTC stack. So, for example, one of the things we do is play YouTube videos in sync to everybody who's on the video chat. When that happens, we reduce the video chat resolution frame rate so that we can still continue to play the YouTube video. Additionally, you can account for this played video resolution. So the resolution, in our case, changes all the time. So depending on what you're doing in the app. So there's no need to receive a nice HD 720 stream when you're only displaying it at a small 160 by 161 reduced square video resolution on the device. So we adjust based on that as well. And lastly, we're going to adjust based on the number of streams you receive and the resolution. So again, you may be able to do one high-res stream, but as more people come in, you're going to drop the resolution. So what does this look like in practice? So here's a real-life example. We have a Nexus 6P and an iPhone 4S, and you'll see the iPhone 4S is struggling at a measly 72 by 72 at 15 frames per second. And that's going all the way through, nothing being done on the server and received by the Nexus 6P. In this case, the Nexus 6P is only publishing at 104 by 104 and 15 frames per second. And that's not a limitation of what it's capable of doing. That's a limitation that it has negotiated with the server because it knows that there's only iPhone 4S on the other side, and that's all that it can handle. So now, let's add a third device. So now iPhone 6S comes in. What happens now? Well, now the Nexus 6P can start publishing at 720 by 720 at 30 frames per second, and that's going to go to the iPhone 6S because it's a powerful device. Similarly, the iPhone 6S is going to publish that high-res stream, and the Nexus 6P is going to get that. And then the iPhone 4S is going to get 2 new low-resolution streams and low frame rate streams. So the server is going to be dropping frames and transcoding in that case to handle that. So, that's all.
How much like device-specific metadata are you sending to the server? Or is the server just?
Yeah, so the server has basically a table about all the iOS devices, and Android devices basically it's like CPU and memory, those kind of things, and that as well as some user-specific devices like the Nexus one and stuff like that to make sure that those work well. But the others are basically just extrapolated from the CPU and the memory settings. Yes.
I have 2 questions. One's about the speed versus the resolution.
Yeah.
Why do we always want to have fast resolution? Because we see the people here. One frame that was per second that was nice. It would be nice then, 15 or how many they're muddy. That's the first question. The second question is about getting this, about how much of this right now is available peer-to-peer, or is everything still involving the middle guys?
Yeah, okay, so those are good questions. First one is on trade-offs of resolution and frame rate. And so on that, what we've preferred and what we've settled on is that we want a higher frame rate, even if it means a lower resolution. And the reason for that is really just to make you, the mobile devices screens are relatively small, and so having that motion makes it feel more like video and make it feel more like you're actually part of it. You notice, it's a little harder to notice some of the lower resolution on a smaller screen. So we found that that's the trade-off that we've liked. And then the other question was on can you do peer-to-peer, if it's a one-to-one case versus always going through the server. Currently we go through the server, but that's an obvious thing to do, and so that is something that we're working on. And the trick there is to maintain the continuity of the video chat, the audio and video, as you're doing that switching, doing that handoff. So that's it's just something we haven't implemented yet.
For the frame dropping, do you have to set up the temporal layers on the endpoints so you can just
Yeah, I mean, so we use the default configuration WebRTC, which has 3 temporal layers. You can reconfigure those as well, but that's how it's configured, and we've been using that. So you can drop there's 0, 1, and 2 layers, and drop layer 2 and go down immediately to half the frame rate.
What video server did you use, and how many independent sessions of video conferences on one server can you handle?
Yeah, so it's all built entirely by us. So the only thing we use right now is the WebRTC SDK. And so it's all C++, C++ 14, and it doesn't crash. So number of people it supports in the hundreds, and we're working on improving that as well.
Total in the server?
Yeah, in a single server.
One session of 100 people.
Oh, no, sorry. Hundreds of streams on a single server, and we currently limit it to 6 people in a single video chat.
Have you tried SFU or
Any other like servers or anything like that? No. I mean, our needs were very specific, so no, it's.
Is there an example where you your stream behind device and lower device?
We're always sending one stream.
So the media stream handles splitting.
Yeah, the server itself is handling redistributing that stream by sending it.
Yeah.
Networks when they're geographically dispersed.
Yeah.
Team in Europe, team in certain dollars, team in Argentina. You're all using the same thing.
两个人放在一起说话有问题，这个发现学校回音很大，各种回音。按理说应该有带自动去噪的。去噪的这种回音可以去不了，因为两个在说话的两个等于是离得很近嘛，离得很近，所以是真的说话。然后并且它这个我这个扬声器播放，你这个扬声器播放声音，然后它也没有收音。
That's something.
过滤掉扬声器的声音。
按理说它是声音比较小，
我说的声音比较大，它会去噪的时候就把那个低非常低的声音和非常高的声音全部去掉，它会把节目和播那个鼓里去掉的。它去噪主要是做这个事情。按理说年龄的常用的是。这聊了多少人没听到吗？聊了多少人没听到？
It can add latency, and then that's the question he was asking. On a one-to-one, if you can do it peer-to-peer, that's ideal. But Right. Yeah, so the peer connections are terminated on the server, so the server is doing a little bit of buffering, latency adjustment. So by the time it's sending it out, it is resending it out basically in sync at that point.
Thanks, Tom. Now for our last talk, we've got Justin from Google for the WebRTC team. Hey. Join him as well. Thanks for bearing with us in the heat. Thanks.
It's been a long day for this notebook. If you just asked, I would have given you a selfie too. Sam, do you remember the shortcut for full screen?
It's like control
Option, control left.
There we go. All right. Yay. All right, let's see here. Let's get back to the beginning. Okay, so let me say, it is great to be here at Twilio Mountain View. And the reason I say that is, we said earlier we didn't have time to do a session this year at Google I/O. And so, yeah, frowny face, kind of sad about that. But the truth is we are so focused on the products we are announcing this morning at Google I/O that we just wouldn't have the time to commit to doing a Google I/O level talk. And Sam certainly knows the amount of work that goes into one of these types of presentations. It's just enormous. So that's why it's great to have this opportunity to be here with you all in this casual setting where we can just talk about WebRTC tech for a few minutes. So there's a bunch of stuff that's been happening with WebRTC over the past year. And in fact, over the past 5 years. On June 1st, WebRTC will be 5 years old. This is a big deal. We've accomplished a ton in 5 years. I often like to say you underestimate what you can do in 1 year. You overestimate what you can do in 1 year, but you underestimate what you can do in 5 years. Almost blew that. But let's take a look back at where this all started. So this was the original email that went out to announce WebRTC. And you can see here it talks about a mission, and it talks about what it wants developers to do. The mission was to make audio and video available in all browsers and to allow developers to create voice and video apps on the web. Well, I think we really succeeded in that. We've seen a lot of great apps, everything from distance learning to telemedicine to peer-to-peer CDNs. And we're finally seeing WebRTC become truly ubiquitous. Chrome and Firefox and Opera have had support for WebRTC for quite some time, but this year we see Microsoft release Edge with built-in support for ORTC, which then can be used with WebRTC apps, the adapter.js shim. And here at their most recent conference, they announced they're going to support native WebRTC, interoperable H.264, and VP8. So we finally got to this point where these browsers all support WebRTC, and they all support the same format so they can talk to each other. It's truly an incredible moment. So the last piece in the puzzle, no discussion of WebRTC would be complete, but we're finally seeing motion on the Apple side, where patches are landing in WebKit. You can see this year things from media streams and other stuff going into WebKit, and even an Apple job posting for WebRTC engineers. So I'm keeping my fingers crossed that this year, WWDC 2016, is when it all comes together. So let's talk about numbers. Now, previously, I got a lot of attention for the stat of 1 billion WebRTC endpoints. Well, I'm excited to say that between the over 1 billion Chrome for Android endpoints and the hundreds of millions who are using desktop Chrome, Firefox, and now Edge, we are well over 2 billion WebRTC capable endpoints. And these endpoints are active. From our opt-in, anonymized metrics in Chrome, we calculate that just Chrome users are sending over 1 billion minutes of media per week. That is over 2,000 years. Sometimes I think that audio-video, though, gets all the focus, and data channels are overlooked. Well, I want to say we've seen amazing growth in data channel usage as well. A huge ramp in data usage. Chrome data channels are currently moving over 500 terabytes of data every single week. And this graph is up and to the right. While there's still a way to go, data channels are becoming a real factor on the web. We're now moving 0.05% as much traffic as all the rest of the web combined. And it's still only 0.05%, so don't get too excited. But, you can still imagine this is something that, this trend continues,
data channels could be a significant fraction of how data is exchanged on the internet. And getting back to the mission, this is what we hope to accomplish. We're seeing it happen now. So data channel application developers out there, I know you're out there, keep it up. The other thing that really makes me excited is the growth in the overall WebRTC ecosystem. There's close to 1,000 companies building their businesses on WebRTC. And these aren't our numbers. These are the figures coming from Chris's partner, BlogGeek.me's one and only Sahi, who's tracking this and basically seeing this not just at nearly 1,000 companies, but almost double year-over-year growth, 70% growth in the WebRTC ecosystem. And it's truly a global phenomenon. This is a readout from Google Trends of the countries that search most for WebRTC. You can see that the US, which all of us are in right now, just to be clear, is not even in the top 7. So we're talking about redefining communications. It's one thing to redefine communications in markets where communications are already well established, like here, but there are other markets where communications, like there was no great PSTN infrastructure, and WebRTC is sort of helping that communication come into existence. So I find that extremely exciting. Another thing that gets me excited, there are many, is people actually building businesses and being super successful by making a great product and selling it. And we've seen over 30 acquisitions in the WebRTC space to date. We just heard from Airtime, who acquired VLine. And I know on a personal level, some of the folks at Jitsi and Screen Hero, who made terrific, they're very early innovators in the WebRTC space. They made a great product, and they're rewarded for their accomplishments. And I think that's truly a great startup, or a great story for any startup. So we talked about the web. We're also seeing terrific adoption of WebRTC on mobile as well. WebRTC is powering, we see like the top apps on mobile are in very way communications apps. In the top 10 is all messaging and voice and video communication. And WebRTC is powering these major apps. Facebook Messenger, Skype, or not Skype, Facebook Messenger, Viber, dialing list. That'd be great, but Facebook Messenger, Viber, Snapchat, our own Hangouts, and Slack, all being built on top of WebRTC. It's like, when you're designing a new app now, there's no reason why you wouldn't use WebRTC. So, enough about stats. Let's talk about some of the new APIs. And Sam's going to come up here and help me talk about some of the new stuff that's gone into Chrome recently. I'll first start talking about ECDSA certificates. This really should be transparent to most applications, but if you have a middle box that is like not a browser that WebRTC is talking to, you may need to pay attention to this. As for Chrome 47, you can start using ECDSA. And what ECDSA does is it means that your first run of your application is much, much faster. Because generating an RSA key takes a long time. Typically, on a desktop, it might be 500 milliseconds, but on a mobile phone, you seem to take like 6 seconds on like a slow phone. So like moving to ECDSA is like instantaneous. Second thing is that now, since it's fast, you can generate a new certificate for every call, which gives more privacy because there's no tracking of like the certificate between calls. And lastly, the actual ECDSA algorithm is considered to be about as secure as RSA 2048. So it's almost like we're doubling the overall effectively key size with these certificates. But the short answer is it's more secure. It might break your app if you have a middle box. You should test it out with the Generate Certificate API ahead of when we throw in the default, which will be in the Chrome 52 timeframe. All right, so I'm going to talk about Media Recorder.
Yeah, let's have a short commercial break while I show off a couple of demos. So the first one, so we can get this in here. I just wanted to show off Media Recorder. I don't know if people have seen this. This is an API for recording audio and video on mobile and on the desktop. So yeah, it's in Chrome and Firefox and Opera. Supports local and remote streams. So it's a powerful API getting us away from hacks for recording media. VP8, VP9 support, obvious audio. I just wanted to actually show that in action. I don't know if people have actually seen this. Do we click on it over there? Yeah. So this is like, your basic demo. This will run on. I get this right. It's like we'll run on Chrome Dev on Android at the moment. Experiments. Oh, come on. No connectivity. Oh yeah, you're right. Remember password? Well, hang on, you could use. We can tether this. 1 second for a technical break here. But basically, this is supported on Chrome on Android now. I forget the exact details, but essentially, if you use like experimental platform features flag, you'll be able to run that now and record stuff to like with Chrome on Android. The other thing I'll show you there just briefly is I'll mention while Justin's doing that is my colleague Paul Lewis made a demo called Voice Memos. It's a kind of progressive web apps demo. The nice thing with that is he's moved that over to Media Recorder with a fallback to Recorder.js. So it's a kind of nice example of the ability to use these new APIs with a decent fallback for people who are on older machines. There we go. Hey, is that going to work? Yeah, I'll hit buttons. Okay. Oh yeah. Okay, fine. So you need using carry. That's a great demo. Yeah, this is really good.
Coming up in colors?
Yeah. That's very true. What is it? Media Recorder. There you go. Ah, correct. The split screen. Trying to get too fancy with the split screen, I think is really what it comes down to. Sorry, I got it here. All right. Okay. Yeah, I mean, this is pretty straightforward. We're recording the stuff from user media, and then playing back. Come on. All right. I think it's just we'll do the sound as well. Media, and then playing back. Come on. All right. I think it's just media, and then playing back. Come on. Media. All right. I think it's just media. Playing back, and then playing back. All right. I think it's just. All right. I think it's just media, and then playing back. Yeah. So come on. Next. All right. I think it's just media, and then playing back. Come on. All right. I think it's just media, and then playing back. Come on. All right. I think it's just media, and then playing back. Come on. All right. I think it's just media, and then playing back. Come on. All right. I think it's just media, and then playing back. Come on. All right. I think it's just media, and then playing back. Come on. All right. I think it's just media, and then playing back. All right. I think it's just media, and then flying back. How many Golden State fans? All right. I think it's just media, and then flying back. And then we should. All right. I think it's just media, and then flying back. All right. I think it's just media. Oh yeah. And then flying back. Oh yeah. It's great to be here. Yeah. Swimming on mountain. Flying back. That's beautiful. All right. I think it's just how many Golden State fans are there in the audience? All right. I think it's just media. And then flying back. The other thing I wanted to show off is. All right. I think it's just media. And then flying back. All right. All right. I think it's just media. And then flying back. All right. All right. I think it's just media. And then flying back. All right. All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back. All All right. I think it's just media, and then flying back. The latency is all right. I think it's just media, and then flying back. We can also. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back.
Can actually get to campus then.
All right. I think it's just media, and then flying back.
Record it.
All right. All right. I think it's just media, and then flying back.
Or color boost. Or
all right. I think it's just media, and then flying back.
Yeah, if you go
to
the.
All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back.
Chrome stable.
All right.
Yeah.
All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back.
So screen sharing.
All right. I think it's just media, and then flying back.
Screen sharing picker in Chrome.
All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back.
Coming in addition to this one.
All right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back.
Working on.
All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back.
Or something.
All right. I think it's just media, and then flying back.
To the other side.
All right.
So
all right. I think it's just media,
sort of thing.
and then flying back.
Now could have been great.
All right. I think it's just media, and then flying back.
So that's
all right.
It's
all right. I think it's just media, and then flying back. All right. All right. I think it's just media, and then flying back.
Now, it's got a flag.
All right. I think it's just media, and then flying back.
We actually get the
All
URL.
right. All right. I think it's just media, and then flying back.
At least in Connect.
All right.
We'll have this.
All right. I think it's just media, and then flying back.
Sharing
All right.
through.
All right. I think it's just media, and then flying back.
If you
All right. All right. I think it's just media,
using screen sharing,
and then flying back. All right. All right. I think it's just media, and then flying back. All right. All right. I think it's just media.
All right.
And then flying back.
Let's talk about some of the stuff going on underneath there.
All right. I think it's just media, and then flying back.
There's some discussion about mesh.
All right. I think it's just media,
and how.
And then flying back.
You have to have a.
All right. I think it's just media, and then flying back.
That's all true.
All right. I think it's just media, and then flying back.
Improvements to bandwidth estimation.
All right. I think it's just media, and then flying back.
Better.
All right.
Sort of share.
All right. I think it's just media, and then flying back.
TCP forms.
All right. All right. I think it's just media,
algorithm.
and then flying back.
He reduces its rate.
All right. I think it's just media, and then flying back.
Algorithm.
All right. I think it's just media, and then flying back.
Not lose any packets.
All right.
He gives up.
All right. I think it's just media, and then flying back.
So bad they just show
All right. All right. I think it's just media,
someone's down
and then flying back.
Shared internet link.
All right.
That doesn't.
All right. I think it's just media, and then flying back.
So this is just one step.
All right. I think it's just media, and then flying back.
Seconds to get up to HD. Now,
all right. I think it's just media, and then flying back.
You continue to make.
All right. I think it's just media,
a lot of people complain.
and then flying back.
Estimation is not working well. Customers complain.
All right. I think it's just media,
This is a problem.
and then flying back.
Infinitum.
But
we think.
All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back.
Didn't work.
All right. I think it's just media, and then flying back.
We've got a new option.
All right. I think it's just media,
and now allows us
and then flying back.
Actually happening inside the call.
All right. I think it's just media, and then flying back.
Why bandwidth estimation was.
All right. I think it's just media, and then flying back.
And also things are in the chat box where people say.
All right. I think it's just media,
or it was.
And then flying back.
Now we actually see like what.
All right. I think it's just media, and then flying back.
Try to do error correction.
All right. I think it's just media, and then flying back.
Use that to debug.
All right. I think it's just media, and then flying back.
Here's how you can activate it.
All right. I think it's just media, and then flying back.
This new checkbox. There's a lot of.
All right. I think it's just media, and then flying back.
There's no media data here. It's all.
All right. I think it's just media,
data about the call.
and then flying back.
Get a file.
Attach the file. All right. I think it's just media, and then flying back.
I encourage you all to try this out.
All right. I think it's just media, and then flying back.
These files, and you can collect them.
All right. I think it's just media,
format is actually
and then flying back.
If you want to try to code it.
All right. I think it's just media, and then flying back.
Things we hear about is.
All right. I think it's just media, and then flying back.
Using Chrome on Mac, and their mic doesn't work.
All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back.
And they assure me.
All right. I think it's just media, and then flying back.
We fixed it.
All right. I think it's just media, and then flying back.
Inside of.
All right. I think it's just media, and then flying back.
And that was a bad state. It was really hard.
All right. I think it's just media,
sort of putting this one
and then flying back.
Thing. So.
All right. I think it's just media, and then flying back.
We think of section 52.
All right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back.
Often have a lot of glitches.
All right. I think it's just media, and then flying back.
These are usually downloadable.
All right. I think it's just media, and then flying back.
For is echo canceling.
All right. I think it's just media, and then flying back.
There'd be one good sync.
All right. I think it's just media, and then flying back.
Algorithms to understand.
All right. I think it's just media, and then flying back.
And so it's
all right. I think it's just media, and then flying back.
And then suddenly it jumps by 20 milliseconds.
All right. I think it's just media, and then flying back.
Where like your call suddenly.
All right. I think it's just media, and then flying back
at some point in time.
All right. I think it's just media, and then flying back.
The problem is actually an issue.
All right. I think it's just media, and then flying back.
And play out.
All right. I think it's just media, and then flying back.
This is something we're spending a ton of time on. Just
all right. I think it's just media,
making sure
and then flying back.
The call becomes unusual because.
All right. I think it's just media, and then flying back.
Gone for
all right. I think it's just media, and then flying back. All right. I think it's just media, and then flying back.
This is where.
All right. I think it's just media, and then flying back.
iOS has a very.
All right. I think it's just media, and then flying back.
Those of you who work on iOS certainly know this.
All right. I think it's just media,
do it that way,
and then flying back.
And one specific way this.
All right. I think it's just media,
audio content,
and then flying back.
If you don't sort of work with that properly.
All right. I think it's just media,
doesn't have the right volume,
and then flying back.
Play it out at all.
All right. I think it's just media, and then flying back.
And that the application can have.
All right. I think it's just media, and then flying back.
And when the application plays.
All right. I think it's just media, and then flying back.
If you're interested, the details are very.
All right. I think it's just media,
everything,
and then flying back.
but we now have much better.
All right. I think it's just media.
Also,
and then flying back.
For hardware acceleration on iOS.
All right. I think it's just media.
We've seen some.
And then flying back.
We ask it to produce 100 kilobits.
All right. I think it's just media. And then flying back.
Maybe give you 400. It says, okay, I'll give you 300.
All right. I think it's just media.
And this way,
and then flying back.
A wrapper that kind of takes a more.
All right. I think it's just media. And then flying back.
And the overall thing is that.
All right. I think it's just media. And then flying back.
Over the lifetime call.
All right. I think it's just media.
We've also updated
and then flying back.
With overall Objective-C paradigm.
All right. I think it's just media. And then flying back.
To API.
All right. I think it's just media. And then flying back.
For forever. Is can you just make.
All right. I think it's just media.
Into.
And then flying back.
And you.
All right. I think it's just media.
Publish it.
And then flying back.
A few weeks.
All right. I think it's just media.
Download this.
And then flying back.
Code and off running your WebRTC.
All right. I think it's just media. And then flying back.
1,000 steps required to compile, build.
All right. I think it's just media. And then flying back.
Okay.
All right. I think it's just media. And then flying back.
Codecs.
All right. I think it's just media. And then flying back.
Video codecs. We haven't talked about audio.
All right. I think it's just media.
We've gotten some.
And then flying back.
It's great. It's so many.
All right. I think it's just media. And then flying back.
This is around CPU utilization.
All right. I think it's just media.
Devices.
And then flying back.
So we've got a team working
all right. I think it's just media.
Really nice improvements.
And then flying back.
A few months of work.
All right. I think it's just media. And then flying back.
15% and decoding.
All right. I think it's just media. And then flying back.
For nothing. Fantastic.
All right. I think it's just media.
Bug fixes.
And then flying back.
Original version of DTX.
All right. I think it's just media. And then flying back.
DTX to actually save you a lot of bits.
All right. I think it's just media. And then flying back.
Sort of ultra low bandwidth.
All right. I think it's just media. And then flying back.
That's like 20.
All right. I think it's just media. And then flying back.
Emerging markets and other sort of situations.
All right. I think it's just media.
It seems like.
And then flying back.
In like 12 minutes.
All right. I think it's just media. And then flying back.
Opus. All right.
I think it's just media. And then flying back.
Solutions with LBC.
All right. I think it's just media. And then flying back.
It should work well.
All right. I think it's just media. And then flying back.
For the CPU settings.
All right. I think it's just media. And then flying back.
Kind of over here on the.
All right. I think it's just media. And then flying back.
Then the corresponding lines on the left.
All right. I think it's just media. And then flying back.
So, like I said,
all right. I think it's just media.
On this for a couple
and then flying back.
Continue to work on this and try to overall.
All right. I think it's just media. And then flying back.
CPU complexity.
All right. I think it's just media. And then flying back. All right. I think it's just media. And then flying back.
Interested in getting your sort of.
All right. I think it's just media. And then flying back.
That would really help this work.
All right. I think it's just media. And then flying back. All right. I think it's just media. And then flying back.
And I promise that this was.
All right. I think it's just media. And then flying back. So, all right. I think it's just media. And then flying back.
In Chrome 52.
All right. I think it's just media. And then flying back.
Or software decode, depending on what you couple.
All right. I think it's just media.
And many Windows.
And then flying back.
So that's fantastic.
All right. I think it's just media.
We've done work.
And then flying back.
52 that would actually interoperate.
All right. I think it's just media.
Firefox.
And then flying back.
And our iOS.
All right. I think it's just media.
So.
And then flying back.
That once. Edge.
All right. I think it's just media. And then flying back.
They certainly currently support their own spectrum.
All right. I think it's just media. And then flying back.
Which uses for.
All right. I think it's just media.
We'll be able to interoperate.
And then flying back. All right. I think it's just media. And then flying back. Hold on.
And
all right, I think it's just media.
Back into this demo.
And then flying back. Hold on. All right, I think it's just media. And then flying back.
Make sure I get to some.
Hold on.
Interesting.
All right, I think it's just media.
So VP9.
And then flying back.
One of the earlier presenters mentioned.
All right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back.
More CPU.
Hold on.
You know, or
all right, I think it's just media. And then flying back.
It works really well.
You know, all right, I think it's just media. And then flying back.
Things about VP9 is that it brings.
All right, I think it's just media. And then flying back. Hold on.
And what is XQC?
All right, I think it's just media. And then flying back.
Multiple resolutions.
All right, I think it's just media. And then flying back.
A participant who wants to get.
All right, I think it's just media. And then flying back.
Or somebody on a 1080p screen who wants to.
All right, I think it's just media.
You can set.
And then flying back.
That stream.
Hold on.
And then.
All right, I think it's just media.
That stream.
And then flying back.
So it's really good because.
All right, I think it's just media. And then flying back.
And unlike simulcast.
All right, I think it's just media. And then flying back.
You're sending multiple copies.
All right, I think it's just media. And then flying back. Hold on.
Only like 10.
All right, I think it's just media.
So like really,
and then flying back.
The other thing is that you actually get something for that.
All right, I think it's just media.
Better.
And then flying back.
Because.
Hold on. All right, I think it's just media. And then flying back. Hold on.
Just keep chugging.
All right, I think it's just media. And then flying back.
You're actually getting better.
All right, I think it's just media.
So.
And then flying back.
Kind of complicated way of saying that.
All right, I think it's just media. And then flying back.
Scenarios.
Hold on.
You get a lot.
All right, I think it's just media.
Better than single cast.
And then flying back. Hold on. All right, I think it's just media. And then flying back. Hold on.
We're missing.
All right, I think it's just media.
To control this.
And then flying back.
Ideally, we have some API.
All right, I think it's just media.
How many?
And then flying back.
Temporal layers.
All right, I think it's just media. And then flying back.
And so right now, with Chrome flags.
All right, I think it's just media.
These options.
And then flying back.
Pick your VP9.
All right, I think it's just media. And then flying back.
And that's kind of good enough.
All right, I think it's just media.
The middle box.
And then flying back.
And,
all right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back.
We announced that.
Hold on. All right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back.
It's built on WebRTC.
All right, I think it's just media. And then flying back.
Chrome team.
Hold on.
Which allows us to.
All right, I think it's just media. And then flying back. Hold on.
And
all right, I think it's just media. And then flying back.
Every single
hold on. All right, I think it's just media.
Protocol.
And then flying back.
In order to make this.
All right, I think it's just media. And then flying back.
That's optimization.
Hold on. All right, I think it's just media. And then flying back.
Kind of weird flow.
Hold on. All right, I think it's just media. And then flying back.
Then the other side, maybe eventually.
All right, I think it's just media. And then flying back.
Seconds and labs, something connects.
All right, I think it's just media.
How are you?
And then flying back. Hold on.
It kind of seems that.
All right, I think it's just media. And then flying back.
Like it actually took like an operator.
All right, I think it's just media. And then flying back.
Actually connect the call. It actually makes sense for.
All right, I think it's just media. And then flying back. Hold on. All right, I think it's just media. And then flying back. Hold on.
So,
all right, I think it's just media.
Once we
and then flying back.
Just send the video.
Hold on. All right, I think it's just media.
The call rings.
And then flying back.
You see who's
hold on.
calling.
All right, I think it's just media.
And, so
and then flying back.
And it's one of the centerpiece features that do it.
All right, I think it's just media.
Exactly.
And then flying back. alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then flying back alone. All right, I think it's just media, and then.
So I just want to make sure that the demo we did earlier, like we.
How it improves signaling?
Oh yeah, absolutely. 75% fewer round trips, 75% faster connections than even H2. It's fantastic to be able to like basically obtain data in a single round trip.
Okay.
In the back.
Do you have any updates about error cancellation?
So I talked a little bit about what we're doing to fix glitches, which we think are the root of many of the actual AEC failure issues. Do you have a specific question?
I mean, it sometimes appears and will not go away.
Yeah, right. So that's typically glitches. When it appears and just doesn't go away, it's typically that we have had a problem where we thought we knew where the echo was in the input stream, and then all of a sudden things changed under us, and we got confused. We should do better in terms of not having that happen, but we are also working on improved linear filter and nonlinear processing for the AC algorithm. So, well, I don't have anything specific. We hope that within the next 3 to 6 months, we can make a marked improvement in the overall number of AC failures. Yes?
Is there an ETA on quick data channels?
I tried to answer that a little bit before. A quick data channel ETA, what I'm hoping is that we can, later this year, basically, we'll have something experimental to play with. We're still figuring out exactly how to do the crypto handshake and all that sort of thing, but I think some of the experts in this are maybe in the audience here. Peter Thatcher, oh, there he is right there. You can go pick his brain, and he could tell you exactly a number that he could stand behind, probably. Yes?
But what does Duo and Allo mean for Hangouts?
Wow. So Hangouts says.
What was the question?
Oh, so the question is, what does Allo and Duo mean for Hangouts? And we're not really prepared to talk about that in depth right now. But one thing I will say is that Hangouts does a fantastic job at the group communication scenario. And one of the things that we thought was that that's awesome, but it's hard to be all things to all people. And so what we didn't have was really something that was streamlined and optimized for the one-on-one calling scenario. And that's what Duo was trying to be. And we also found that there's a very large percentage of people who want to make one-on-one calls. Yes?
So you mentioned the large effort around moving to CocoaPods for iOS developers. Is there any similar effort to enable like an AAR or maybe a jar for Android developers that want to?
Yeah, I think the demand wasn't quite as acute on that side, but that's something that we would probably be interested in. I think one of the issues is there's a bunch of different formats to choose from, and trying to pick the right one. Because we didn't have the same demand, we didn't feel compelled to pick one. But if you think that there's something very specific that everyone can get on board with, I think that would be an interesting thing to go explore. Yes, in the garden.
Speaking of screen sharing, and the ability to share a tab, how do you see the picker with like 30 different tabs listed?
That's a fantastic question, because I typically have tabs where I can't even see the icons anymore. But I think when I thought about it, I was like, maybe it's solving the wrong problem of showing all the tabs, and like maybe you just want to show like a MRU list of tabs. Where like you probably want to share the thing you opened up 5 minutes ago or 10 minutes ago, and not the thing that you were planning to work on in 3 days. You opened 3 days ago and still planning to work on. So that's our current way of thinking about it, is that we won't just dump everything in there. We'll come up with a smarter way of making sure that we don't just fill the entire thing with garbage.
The screen share audio capture, is it just the app or is it the entire system?
So we support Tab on all platforms, and on specific platforms, which I believe is Windows and Linux right now, we support system audio. Mac, you can't do it without installing something with root. So we don't think that we can grab root privileges for WebRTC at this point.
And it's all echo cancellation?
Well, I don't think echo cancellation really applies. Echo cancellation doesn't apply outside. So like
if you're on the machine, it's playing out the sound, but at the same time, you also have a microphone that's recording.
Well, the typical use case would be I'm sharing maybe a YouTube video to you. It plays out of your system, and then your microphone needs to echo cancel that so that it's not fed back to me, and that should work just fine. Question over here in the front.
Yeah, so I heard that Allo is going to have an incognito mode that has end-to-end encryption.
That's it.
Can you do anything like that for Duo?
Well, Duo already is end-to-end encrypted.
Oh, cool.
Yes?
Do you have a friend to support the video recording?
In what context?
Duo.
So I'm really not, at this point in time, I can't really talk more about Duo other than the features we already talked about at Google I/O, so I can't really talk about that this time.
You were talking about casting a tab. So can we cast one tab and then use the audio of a different tab?
So I'm not sure I understand the question. Casting. So yeah, I have a tab here that you want to then share with somebody else.
And then I want to share the audio of a different tab. Like I'm playing a music and I'm just trying to do a presentation.
So, like, one of the great things about WebRTC is that I think that we don't tell you what not to do. So you could certainly have two sharing contexts where you get access to one tab with one media stream track, and then maybe access to audio through another media stream track, and you can pretty much do whatever you want to do. I think. I'm not sure we allow you to share just the audio from a tab. That might be kind of weird, but you can figure out muting or other ways where you can do that. But yeah, I think that you can find a way to do it that using the combination of the APIs that exist. Okay, well, I think at 9 o'clock, I think we're right on time. Thank you, everyone.
Thank you all for joining. That wraps up all the talks, but feel free to stick around. We've got some more wine out, some more beer. We'll be hanging out for the next half hour or so. Feel free to chat with some of the speakers, ask any questions you didn't have a chance to. If you have any questions for the Twilio team, we'll be up here. If you want to see more technical content, there'll be a lot more WebRTC content next week at Signal.
Yeah, but that's not quite the
have all these wonderful Yeah.